Okay, so we can hear a little bit more about what Parallelworks has been up to in the last year or two. For those that don't remember, Parallelworks is a commercial company started by Mike Wild and others that uses Parsl in some of its offerings.
Okay, yeah, so I'm going to give an update on the use of Parsl in Parallelworks. I will first briefly talk about Parallelworks clusters, and then I will dedicate most of the talk to explaining how we run Parsl workflows and Parsl Jupyter notebooks on these clusters, and focusing on our goals and stumbling blocks for a Parsl workflow specifically. We have recently added a new type of resource to the platform, which is the Elastic clusters. And this type of resource enables users to provision HPC Slurm clusters in the cloud, or to connect on-premise Slurm clusters to the platform. The cloud clusters have they have the same feel and performance as the on-premise Slurm clusters. They are elastic and highly customizable, and you can leverage the cloud costs or choose between several clouds. And both type of clusters, the on-premise and the cloud, have the uniform API, so the Parsl workflows and notebooks are started the same way in all clusters. To define a cluster, you would simply click on the desired cluster type and fill in some configuration options, and you can choose AWS, Google, or Azure for cloud clusters. We're working on Oracle. And if you have an on-premise cluster that you want to connect, you can choose the existing cluster. Then users can activate these clusters with a power button in a uniform way. And as I've said, the clusters have a uniform API, and there is SSH access from the user container in Parallelworks to to the master node of the cluster. So for example, you can query the Parallelworks API with a pool name and get the address of the controller node, and then you can SSH into the cluster and do your work as you would on a regular cluster. So the question is, how can we run Parsl in these clusters? As I've said, there are two ways, with workflows and with Jupyter notebooks. I will first talk about the workflows. And there are two ways to launch workflows in Parallelworks. One is through the web user interface, and the other one is using the Python PW client. To launch a workflow using the web UI, the user experience would be you click on a workflow thumbnail, then you enter some parameters in a form, you click execute, and that generates a workflow command and arguments that run in the user container. And you can do the same thing with the Parallelworks client to launch a workflow with a Python script. And there's an example of that here on the left. You will only need to tell the client the URL of the platform, your API key, the username, the resource names that you want to use, the workflow name, and the workflow arguments. And this can launch the workflow for you as if you were in the web UI. And you can use the client to automate other applications. And one very good example of this is you can use it to run GitHub actions using the Parallelworks clusters. And you can store your API key as a secret in GitHub. Use this to do CI/CD workflows with clusters. So for Parsl, we had the following goals. We want to move from our custom modified Parsl to standard Parsl, so support any version of Parsl that is out there. And then we want to run the Parsl scripts in the user container in Parallelworks, not in the cluster, which adds some difficulties. And then we want to run different Parsl apps in different clusters, including on-premise and the cloud. And finally, we want users to be able to share these workflows with other users. So when trying to achieve these goals, we find these stumbling blocks. We need to find a way to define the Parsl configuration for these different resources. So we would like to point to the Parallelworks pools by name. And we also need to find a way to manage the Python environment in the user container and in the remote resources, because the Parsl versions need to be compatible everywhere, and there may be other dependencies. And since the user may be sharing the workflow with other users or running it in different clusters, we need to be sure that the Python environment is consistent everywhere. And finally, we need to establish port connections from the workers to the user container, which does not have direct access to the worker ports. So to deal with these stumbling blocks, we're using right now at least a Parsl workflow wrapper that runs before and after your Parsl script. Basically, I'm going to talk about how this workflow wrapper solves the stumbling blocks right now. So to define the Parsl configuration, the user or developer would create a JSON configuration to point the Parsl config of the executor to a parallel works pool. And then when the workflow is executed, the configuration is completed by the parallel works API before execution. And the API adds the host user, the IP of the controller node, and then available worker ports. This JSON is then loaded and used to define the Parsl configuration. And we're using the SSH channel, as you can see, to connect to the controller nodes. And then if you want to run in the controller node, you can use the local provider, as in this example. Or if you want to run in the compute nodes, you can use the Slurm provider or the local provider that calls some Slurm commands. To manage the Python environment, we are using, we're defining it in YAML and Singularity files, and we are including this in the workflow. So you can choose one file per executor and another for the user container. So then the Parsl workflow wrapper optionally updates or installs the Python environment from these files. So if, for example, a user imports a workflow that they get from the marketplace and they don't know about the requirements, they can either point the executor to a different Python environment that they have in the clusters, or they can install this environment manually, or, which was kind of our goal, they can simply launch the workflow and the wrapper will take care of installing this environment for them. And finally, to establish the port connections for the workers, the Parsl workflow wrapper creates SSH tunnels for the worker ports before execution and cleans them after execution. And these are available ports that are provided by the API. And I'm showing an example using the local provider and the Slurm provider. In the first case, it's easier because you only need to create a tunnel from the controller nodes to the user container. In the second case, it's harder because the tunnel needs to come all the way from the compute partitions of the clusters to the user container. Then the other way in which we can run Parsl in our clusters is with Jupyter Notebooks, which is a far easier approach because the Parsl script is actually running in the cluster in this case. Our goals here was to connect from the user container to the Jupyter server and to automate the server launch so that it is easy for users. And the approach is basically that the Jupyter server runs in the controller node of the Slurm cluster, and the server port and only the server port of Jupyter is tunneled into the user container, which has the limitations that you can only use one cluster per Parsl job, but you can use multiple partitions. For automation, we are using Parallel Works workflow to start the Jupyter server, and there are many different workflows to do this with different default parameters. So the idea is that the user simply clicks on the workflow and executes it. When the server is ready, it pops up in the Parallel Works interface. You can enter your password. And then if you have a Parsl script in the cluster, you can basically just click on it and send jobs to different partitions using the Slurm provider as you would on a regular cluster. Then when you're done, you can simply go to the workflow monitor, kill the job, and this will clean up everything for you. As potential next steps, we are trying to implement the failover in Parsl workflows because people is very interested in that. The idea is basically we want to associate multiple resources with a given Parsl app, and then these resources are ranked. So if the app fails in one resource, it will try on the second one. And from a user experience perspective, we want to streamline the definition of the Parsl configuration through the web UI so that the user doesn't have to edit a big JSON file that decides the entire configuration of Parsl. So thank you very much. And if you maybe have a question.
Alvaro, questions, everyone?
Yes, just wondering about when you're doing things through the web versus through command line or through some other means. It seems like that hurts reproducibility. Do you have any thoughts about that?
If it hurts?
Yeah.
It doesn't really. It's basically just like clicking. It's the same thing as running the workflow manually through the web UI. So basically what I usually do is I first run it through the web UI and then I kind of export the parameters and then I put that inside the Python script. So then you can reproduce that run as many times as you want.
So I think you still basically write the script almost in the web UI, right? Like you can always see the equivalent of the Parsl script underlying the application.
Yeah, it's the same Parsl script. You're just using the Parallel Works platform in an automated way with Python.
You have like a Jupyter interface in Parallel. I mean, the interface for Parallel Works is amazing with the little bars and whatever you call the compute clusters.
Yep.
It looks very slick. Does this work with like Amazon has essentially a Slurm cluster on demand, right?
Yeah, that was like our first version, but we're moving away from that to have like a uniform way of provisioning them with Terraform and Ansible. So we still support that, but it's not our preferred option.
And the advantage is cross-platform, cross-cloud.
Yeah.
You do the same thing in different clouds. The negative is potentially cost, is it?
I don't think so, but many users are kind of familiar with one way or another, and also the cloud vendors want you to use their approach instead of something general. So that's, I think, the main disadvantage.
And if people out there want to try Parallel Works, can you go to the Parallel Works website and get started, or do you need to speak to you? Or
before they could, but now they would need to contact us somehow.
Definitely worth a look if anyone's interested in the graphical UI to this whole ecosystem. Okay, thank you, Alvaro. Thank you to the 7 speakers before that. We're probably roughly a third of the way through now. Parsl Fest 2022, or Parsl and Funk Fest. We have a 30-minute break.